In our last lecture, we saw the different types of sources. Um, these are the ones which can share us structured data, unstructured data, semi-structured data, or there can be batch and real-time data. In this session, we'll have a look at the different type of storages, the data storages that we would need to store this data, to process this kind of a data, and to consume data uh, from these storage systems. Okay, so on what basis do we select the storage? Okay, now the storage can be of, in the data world, it can be of three types. Okay, there can be a warehouse, there can be a data lake, and there can be a lake house, which is a new concept relatively. So how do we decide on that? Okay, what kind of storage you would need? See, it depends on two things mainly, right? Also depends on the source system, which is sending us the data, and our consumption. Okay, consumption workload, right? Whether we want to do some BI on top of it, we want to generate some reports, or is it like we want to do some AI ML kind of a workloads? And also it is based on the source system, whether we are getting streaming data, whether we are getting unstructured data. Okay, so based on that, it is a choice that we have to make, whether we would need a warehouse or a data lake, or in fact a lake house. Okay, now let's try to understand these in details. The very first one is warehouse. Okay, so warehouse has been there since long time, right? Almost more than couple of decades. Maybe in the late 90s or mid 90s is when a lot of enterprises started using warehouse. Okay, now what is a warehouse? Warehouse is, you can consider, is it's like a storage for your structured data, which can be used for generating BI reports. Okay, if your workloads is mainly around BI, you can use something like warehouse. Traditionally, right, it has been defined as a subject oriented. Okay, this is the old definition which has been there for a long time. Integrated, uh, time variant, time variant, that means it will change with time, and it is non-volatile. Okay, we'll store everything which is there in a warehouse, we are not going to delete anything. Okay, so it is subject oriented, as it is in specific to a particular subject like marketing, sales, or account. It is integrated because we integrate data from multiple source systems. Okay, see, you are getting customer data from different types of sources. It can be, one can be your ERP application, the other can be, in fact, some CSVs also from where you are getting the data. So all this in the end get integrated and it is loaded into the warehouse. So this is how a warehouse is defined, and it was mainly for your structured data. Okay, the tools, what were the tools on which it has been built on traditionally, right? There were tools like Netezza, Teradata, Oracle Exadata, where we used to create a warehouse. Now, the workload, right, that it supports was only BI workloads. Okay, this would only support your BI kind of a workloads, your reporting and dashboards. Also, the other thing is, it won't support streaming kind of a use cases, right? There might be some near real time of use cases where you can get data within lag of say 5 minutes maybe, but when it comes to streaming workloads, it would not be able to support that. And again, the third thing was, this as I said about the products, right, these were all the proprietary products, right? You cannot really use any other compute engine, open source compute engine, to get data directly out of this storage. Okay, um, and that is where, right, data lake started coming into picture somewhere in around 2010, right? When Hadoop started gaining a lot of popularity, people started using a data lake. Okay, now what is data lake? Data lake is just a storage where, like, in the current times, right, any cloud object storage like S3, ADLS, Google Cloud storage can be used for creating a data lake. Now it is where you can store all your unstructured data. Okay, all your unstructured data. It is built on commodity hardware. Like when Hadoop came in, people started using HDFS for building their data lake, right, which was Hadoop's file system. And nowadays S3 or ADLS is what is generally used in most of the enterprises for data lake. Now, what is the advantages of using data lake? It can support your other use cases, right? Like your AI ML use cases, which needs unstructured data, right? Lot of unstructured, semi-structured data. So your data lake was capable of handling these kind of data, or storing these kind of data, and also getting the um, support, or providing the support for AI ML use cases. But at the same time, there was some disadvantages, right? Now, what were the disadvantages or limitations as compared to warehouse? So the biggest one was, like, you cannot do an updates in a data lake. Okay, it does not support your acid level properties, which generally a database and data warehouse supports. So if you want to update a single record, it was very difficult. You'll If you had created some hive tables on top of your data lake, you would have to delete that partition, recreate that, even for a single record. So that was a problem. Even performance was a challenge, because it was not as performant as the other warehouses. So that was another bigger challenge. But at the same time, right, since it was supporting AIML, it was cost effective, it started gaining a lot of popularity. And with Hadoop, right, many people started moving to data lake. Now there were also enterprises who started implementing both. Okay, data lake plus, you can say, a data warehouse. All your unstructured data would go to your data lake, which can be used for AI ML kind of use cases. All your structured data will go to your warehouse, where BI reporting kind of use cases can be supported. And of late, right, recently, maybe from last year, there is a new terminology called Lakehouse. In case you are not aware of it, let me quickly explain that. So people have started now using Lakehouse. Now Lakehouse is has as the name says, right, it is a combination of a data lake and a warehouse. But in fact, it is a, I would say, a data lake which has the properties of a warehouse. Okay, so it is still built on object storages like S3 and ADLS. Okay, it's a data lake. Okay, but it uses something called as the open table formats. Okay, so data lakes were your S3, ADLS, where you would save files. Okay, the files would be in Parquet format, Avro format, right? These are the various files that we generally use in a big data world, or the cloud warehousing world. Now Parquet and Avro files would be there. Plus there are open data formats like Hive, right? Hive was a table format where you can create a table on top of HDFS. Very similarly, there are other table formats like Apache, Iceberg. There is Databricks has come up with one called as Delta Lake. Okay, and there is also another one called Apache Hudi. Okay, so these are the open table formats. Maybe we can discuss about these in details in some of our subsequent videos. But this is how a lake house is built. So you have the object storage as the S3 ADLS, where you can store your files, the data files. Then you have the open table formats either in Iceberg, Delta Lake, or Hudi. Okay, this together forms a lake house. Now what are the advantages of this? And then I'll write this in green, because these are all some very very important benefits that you will get out of this. It's open. Okay, the biggest one, it's not like a proprietary like any other, some of the warehouses, where once you store the data, you need also the compute engine of the same. Example, Snowflake, right? If you have now added your data in Snowflake or Teradata or Exadata, right, you will have to compute it, you will have to run queries within the same system. Okay, so it's not open. But in Lakehouse world, it is open. So you can store the data into S3 using as Parquet with, let's say, Iceberg or Hudi, and then you can use Spark engine to compute the data. So here you have a separation of your uh, storage and compute. Okay, these are completely separate and open, and you can use any other compute engine also to fetch the data from your storage. At the same time, it is also performant. Okay, performance is good. as compared to data lakes. If you remember data lake, the performance was a challenge. It also support acid properties, updates, time travel. Okay, if you are aware of what time travel is, like if you have updated some table and if you want to go back and in time and see what was the data before, you can still do that. So your lake houses has all these advantages. Okay, it is open, it is cheaper as compared to warehouse. Performance is as good as a warehouse. It can support your asset transaction also, so you can get to put it in simple words, you will still have to pay the cost of a data lake, but you will get the performance and the other benefits of a warehouse. That is where lake houses are started gaining so much of popularity in today's times. So yeah, so these are the three choices where you can land the data. There are few others also in case you want something like NoSQL or streaming database which has very low latency, sub-second or millisecond latency. We will cover that later, but at a high level, as of now, remember this: there is a warehouse, there is a data lake, and a lake house. Warehouse is mainly for your structured data for BI reporting workloads. Data lake is for unstructured, semi-structured data, which can support AIML use cases. And Lakehouse can support all these use cases, any kind of data, even in streaming real time, it can support. It is open. It can give you the performance of a warehouse, but at the same time, the cost is not as high as any other warehousing tools. So that's it for this lecture. We'll come back later again for rest of the series. Thank you for listening.